Okay, so we are moving on from equations to inequalities this week. And the first thing that we're going to talk about is some of the similarities and some of the differences between equations and inequalities. They have a lot of similar properties, but then they have one major difference that we'll talk about throughout the week. So I am in our book on page 493. I'm going to do the hands-on activity 1 and 2 with you so that you know what I want you to do for the investigate part. So our question is how is an inequality like an equation and how is it different? Mr. Noom Kenya volunteered to drive Hinto and his friends to the school dance. The car can carry up to 5 people, including the driver. How many friends can ride in the car with Hinto? So first of all, when we're given a story problem, we always got to figure out what do we know, what do we need to find. So what we know is that, I'm just going to call Mr. N, volunteered to drive Hinto and his friends to the school dance. We also know that the car can carry up to 5 people, and that's including the driver. What we need to find is how many friends can ride in the car with Hinto. So you can kind of fill out those questions. If you need to pause the video, please do that. When we talk about this inequality that we're going to write, though, when you go in a car, you don't always have to have the maximum number of people in the car. So if you have just a regular car, you have a front seat, a passenger, and then usually you have 3 seats in the back. So you would have a maximum of 5 people. But you don't always have to have that car full. You can have 4 people, you can have 3 people, you can have 2 people, you can have just the driver. So that's why it's an inequality and not an equation in this case. And since we know that the maximum number in the car that we can have is 5, our alligator always eats our biggest number. But since it could equal 5, because I could fit 5 people in the car, we also have the equal to sign. So that would be the maximum number. Then we also have Mr. N and Hinto. So we have 2 people that are already determined in the car. But then we can have an additional amount, and we're going to say X because we don't know what that is. So that's how we get our inequality for this problem. So if you look down there on in the hands-on activity, it kind of breaks down what we already talked about for our inequality. For step 1, we're going to use a balance model to solve this. So on one side of the balance, we have a paper bag, and that's going to represent X, because we don't know what's in that paper bag. But then we also know that we have 2 people already determined in the car. So then we're going to add 2 cubes to model X plus 2. On the other side of the balance, we're going to have our maximum number of people, which is 5. So we put in 5 cubes. Now you can see our balance isn't even because we have more cubes on this side than we do the other. So to solve this, we're going to add 1 cube to the bag at a time and complete the table to figure out what's the maximum number of friends we could have in the car with us. So if I have 1 friend, that means I have 1 person plus Mr. N and Hinto, which would mean I have 3 people in the car. So I'm going to add 1 cube there. So is 3 less than 5? And we would say yes. So then I'm going to say, what if I have 2 friends in the car? So I'm going to add another cube. So now I have 2 friends plus Mr. N and Hinto, so that means I have 4 people in the car. Is 4 less than 5? And that's true. So then I'm going to add another cube. So now I have 3 friends in the car, plus Mr. N and Hinto, which gives me 5. Is 5 less than 5? And I would say no, but is it equal to 5? 5 is equal to 5, therefore, yes, that's still true. Okay, so then I'll add another one. So now I have 4 friends in the car, plus Mr. N and Hinto, which gives me 6 people. So is 6 less than 5? No. Is it equal to 5? No. Therefore, I know I can't have 4 friends in the car because I don't have 6 seats. So I could have up to 3 friends ride with Mr. Hinto and Mr. N and Hinto to the school dance. I don't have to have 3 friends. I could just take 2. I could just take 1, or I could take none. That's why there's different answer choices there. But our final answer would be up to 3 friends. So turn the page. Up at the top it says an inequality is a mathematical sentence that compares quantities. The table shows 2 examples of inequalities. So for words, that one is x is less than 2, and that's how you would write it. X and then is less than 2. X is greater than or equal to 4. X is greater than or equal to 4. We'll talk more about the words, definitions, and symbols later this week as well. So to solve an inequality means to find the values for the variable that makes the sentence true. You can use bar diagrams to solve inequalities. So our next activity, we have an airline charges for checked luggage that weighs more than 50 pounds. Maya's suitcase currently weighs 35 pounds and she still needs to pack her shoes. Find the maximum amount of shoes she can weigh, maximum amount of her shoes can weigh, so Maya will not be charged a fee. Okay, so first thing that we need to do is underline what we know. We know that she can have a suitcase that weighs that they're going to charge for a suitcase that weighs more than 50 pounds. We know that she currently has it weighing 35 pounds and she still needs to pack her shoes. We're going to find the maximum amount her shoes can weigh. So we're going to use a bar diagram this time. So down here we have our bar diagram, and this section right here represents the 50 pounds that that suitcase can weigh. Then this other one represents the 35 pounds that she already has packed. In the bar diagram, we're going to write an X besides the bar that represents the weight of Maya's luggage. So we are missing how much her shoes could weigh. So that's going to be our variable X, which is this part over here. This is still the 35 pounds. And then this is still our total of 50 pounds. So again, when we write an inequality, we don't have to have exactly 50 pounds. Our suitcase could weigh 40 pounds. Our suitcase could weigh 45 pounds. It doesn't have to equal 50, so that's why we're using an inequality. We do know, though, that the maximum amount that it can weigh is 50 pounds. So again, our alligator is going to eat the bigger number, and it could equal 50 pounds. So again, we're going to have that equal to line. And then we have, on the other side, the amount that she already has packed, plus the additional amount she needs for her shoes. So there's our inequality. Now to solve for this, we would take our 50 pounds that we have total and subtract that 35 that we already have packed to figure out what could the shoes weigh. And 50 minus 35 is 15. So she could pack 15 more pounds, or she could pack less than that. So she could pack 14 pounds, she could pack 13 pounds, anything that is smaller than that. She just couldn't pack 16 pounds, otherwise she's going to be charged. When you're working on the investigate side, what I want you to do is you're first of all going to write your inequality. And you're always going to have your alligator eating the heavier side. So on this one is heavier, so your alligator would eat that side. And then we're always going to put an equal to sign on it. Since we're not given a specific story problem, we're going to say it could equal the other side. And so the next one, this is the left side is the heavier side, So you would have your sign that way, but on the third one, the right-hand side is your heavier side, so your alligator eats your bigger number. So then you're just going to write your inequality and figure out what number of cubes would need to go in the bag in order to balance out each side. Then on number 4, you're going to use that same bar diagram model that we did in the second activity to figure out the amount of, I think it's a height that they need to grow or something like that. So you're going to do 1 through 4 on page 495, take a picture and submit it to Google Classroom.